Hello, Earth Science. I want to take you through some basics of geologic history, which is the new unit, our final unit that we're going to be studying before we take the Regents. It's a pretty interesting one in my opinion, but you might disagree only because you're teenagers. But I think if you really open your mind up a little bit, you'll find it kind of interesting. It's really about everything that's happened on the Earth from the time that the Earth was formed 4.6 billion years ago until right now, presently today. So a couple things we have to get out of the way first. A couple things that we need to understand right here in this geologic history notes to help you out that I made for you. The first thing I want to focus on is this idea of uniformitarianism. And this is the idea that the processes that shape the Earth today are the same that occurred in the past. And what this really means is that we have to go with an assumption. I say we, meaning humans, scientists, the scientific community. We have to go with an assumption that the processes that govern the Earth today are the same ones that govern the Earth in the past. So, for example, if a rock, an angular rock, was made round today by, say, streams or waves, we can assume that an angular rock may have been made round by streams and waves 1 billion years ago. And you say, well, okay, that's fine. The assumption is really important, though, because we can't really study the past until we have this assumption in place, because otherwise anyone can make anything up. So I could say, well, yeah, I know that waves and streams make rocks round today through the process of abrasion. That's all well and good. We've all seen it because we're humans and we've watched it. But in the past, you see, rocks are made round by little aliens who came and they cuddled them and they held them and they petted them like little babies until they turned around. And you could say, you're wrong. I would say, how do you know? You weren't there, and neither was I. I could be right and you could be right. What's the difference? The difference is one of them is less plausible than the other. So people were not on the planet until 200,000 years ago at best. And the planet has been around for 4.6 billion years. There's a whole boom, big chunk of history that we just have to study, going with a bunch of assumptions because none of us were here to actually look at it. So uniformitarianism helps us to study things by saying, hey, look, these were the laws and the parameters that govern the Earth today. They're probably the laws and parameters that govern the Earth in its early days too, so we'll go with those. The Walk Superposition, the idea that the rocks are at the bottom of an undisturbed exposure are the oldest. We're saying an undisturbed rock exposure is what we're talking about here. So really, what we want to say with this, I'll show you a little graphic. Well, it's not even a graphic, it's just a picture. But here, what we're saying is we have rocks A, B, C, and D. And if these rocks have not been flipped over, if they haven't been faulted or folded, these are all words you're going to learn soon. If this is just left alone, what we're saying is that this rock layer here, letter D, is older than rock layer C. And C is older than B, and A is the youngest. If you say, well, why would that be? Nature doesn't do things nature does things with the least amount of energy possible. Nature is kind of like a teenager, kind of, a little bit. I'm insulting teenagers a lot today. I should stop. I like you guys. But nature does things with the least amount of energy possible. So nature will not say, well, you know, I'm going to put a layer here with a seashell in it, but later I changed my mind. I actually want a limestone layer underneath it. So what I'm going to do is I'm going to pick up that layer and shove some limestone oozy clay in there and let it harden into a rock. There, that looks good. Nature doesn't do that. Nature says, okay, I can't carry this sediment anymore, so I'm going to deposit it. Oh, I don't want to carry this sediment anymore, I'm going to deposit it. And then this one too, and then this one too. So what we get is that the further you go down in a sequence of rocks, you're going to be getting older and older, which means you're really going back in time. So if I were to say, well, which one of these fossils lived the longest time ago, it's probably this guy here, in rock layer D, because he's older than these ones. So that's an important concept to understand too. In this little animation here, you see the layers building up over time, where layer 1 is the oldest, and as we move up the sequence and get into layer 9 and layer 10, those can become younger. And I think you saw layer 10 was squished in there. It was the last layer formed. We actually call that an igneous intrusion, which is a word you've heard before when we talked about contact metamorphism. So keep your eye here. Layer 10 stuck in there. That is the youngest, and it burned layers that were already in place. Now, if you were to just look at this little animation here, I don't think I can pause it, I'm sorry, but keep your eye here. How would you ever know if you were given the complete sequence of rocks, how would you ever know that layer 10 was actually younger than the layers that were above it? Because I just told you that the oldest layer is always in the bottom. Well, to make things a little simpler for you, in earth science, when we have an intrusion, which occurs when magma squeezes in between layers of pre-existing rocks, we usually mark it with these little lines or whiskers right here, just to show you that, hey, these rocks were burned, which will help us put things in place. So in this case here, we have limestone, which is the oldest, and then we have shale, and we have sandstone. Then the intrusion comes last. So, well, how do you know that intrusion came after the sandstone? Well, it burned the sandstone. So what? Well, you have to have something to burn it. Like if you don't have a hand, let's say you don't have hands. It's kind of a sad thought, but let's just say you don't have hands. You can't burn your hand if you don't have hands. So you have to have a hand first to burn your hand. So the sandstone had to be here in order to get burnt. And we call this contact metamorphism, which means that in this little area right here, we have metamorphic rock to our sedimentary rock. If we look at our reference table, you'll find that limestone turns into marble when it's burned. Shale turns into hornfels, yes. And I'm not sure. Slate, sure, nice too. A whole bunch of things. And then sandstone turns into quartzite. And all of these can be hornfels too. Different discussion for a different day. But you have metamorphic rock where we have those little whiskers, and the rest of it's sedimentary rock. And you have igneous rock right there. Okay. A couple other things too. We have folds and we have faults. So when you have regional metamorphism happen where big, huge continents are smashing into each other, if the layers have time, what they're going to do is fold. And if they don't have enough time, what they're going to do is break, in which case you have a fault. I want to show you this example here because this shows in some situations you have areas where superposition doesn't apply. Now, just to refresh, superposition says that the oldest rock is on the bottom. But in this case here, these layers are so extremely folded right here that if we were to actually just look at this sequence here, 1, 2, and 3, it is not the case that the oldest layer is on the bottom. 1 is the oldest layer. I could tell this by looking at the entire section here, but it got flipped on top of 2 and 3, which are actually younger. The same thing here with some pretty extreme folding. 2 used to be maybe somewhere up here, or else this one was down here. They shifted, and now you have 1, which is, again, the oldest layer is on top of 3, which is the youngest layer, so that's out of sequence. But it takes some pretty big tectonic movements to actually cause superposition to fail to apply. All right, restructuring the past. People can figure out what order things happen in by looking at rock exposures. For example, we have 3 layers here. And we just want to look at the oldest one to figure out the bottom one, which is the oldest, which is the bottom, and the bottom, which is the oldest, to figure out what happened first. So we go to the oldest and the bottom. We say, hey, this happened first, this happened second, this happened third. When we write these, there's some words that we're going to want to get used to here. So one of them is the word of deposition. And deposition means to lay down. So if I were to go ahead and analyze this, what I'm going to do is say that I have the deposition of conglomerate, then the deposition of sandstone, and the deposition of shale. Perfect. I was right. I put them in the right order. Conglomerate, sandstone, shale. And if you are sitting in your desk right now with your earbuds in, trying your hardest not to listen to me, but you're still listening, and you ask yourself, how would I ever know what rocks these are? They look like a bunch of weird little designs. These were our map key from the reference table comes in. So I'm looking at page number 7. All right, here's my little code here, okay? Chunky rocks mixed in with some other dots there. Conglomerate. Little dots, sandstone. Little lines, shale. So you'll be using this a lot in this particular unit. Some of you have gotten pretty good at using it in the units past, so I'm not that worried about it, but this is where you find all of your map symbols for both the sedimentary and the metamorphic rocks. So check out this one. We're going to put this one in order. Now, every time you have a step, you have to account for it. It's not just all deposition. So this is a good example to show that. We have the deposition of limestone, which means you lay down limestone flat. The deposition of sandstone, you lay down sandstone flat. Then the deposition of conglomerate, which means you lay down conglomerate flat. Then we have the folding of limestone, sandstone, and conglomerate layers. So, well, why would you do that? Because they're not flat, they're folded. Look. So what I did is I folded them. Because if I didn't fold them, really what I'd be saying is you got limestone, let me draw it real quick here, sandstone, and conglomerate. That's what these first three things said. So if I'm like, well, I'm done, then this thing should look like that thing, and it doesn't. So I fold all the layers. So now they're all folded. Then I have partial erosion of conglomerate and sandstone layers. And what this means is that these guys, the sandstone and the conglomerate layers are missing. You say, well, I don't understand. When I folded them, so we made it this far. So now I fold the layers. What I should see is all of the layers, the conglomerate, the sandstone, and the limestone, all folded in place. But they're not. I only see a little chunk of this conglomerate, and I don't see any, or I'm sorry, and I see pieces of the sandstone missing. The sandstone should be up here, but it's not, it's missing. So partial erosion means that a piece of it is missing. You want to be careful not to say erosion, because when we get to this stage of earth science, if we say something is eroded, we're saying that it's all the way gone. And there will be times where rock sequences in this unit are completely gone, but that's not what we have right here. We have partial erosion of conglomerate and sandstone layers. Then that wasn't really the end of the story. After that, we had the deposition of shale, and then the intrusion, in this case, of granite. I just picked it to be granite for this example here, but you say, well, I know that the granite came after the shale because it burnt the shale. You're getting so smart at this, you're getting so good, and I'm very impressed with you. But that's how we would put this sequence of rocks together, and this is the kind of thing that you will be doing throughout this particular unit. So we're going to get into some vocab in the second part of this video, and some more examples. I'm going to walk you through one. But the best advice I can give you guys right from the beginning is to start at the bottom. Always start at the bottom, even if you feel intimidated by what you see, because sometimes you're given these, you're asked to reconstruct them like we just did here. When I was taking my exam to become a science teacher, there's 3 exams you have to take to become a teacher, and one of them is called your content area specialty exam. It's like earth science on super steroids. Like, do you know earth science well enough to actually teach it? And I remember my part 4 question of this thing was a huge rock sequence. I mean, it was like pages and pages and pages long. I almost panicked. I was like, oh, I don't know what to do. And I remember that my own advice that I would tell to my students when I was still student teaching is like, start at the bottom, start at the bottom. So I went to like page 6 of this thing. I found the first layer, and I'm like, okay, like deposition of breccia. Okay, and then go to the next one. For some of these, once you get rolling, the rest of it will click into place. And practice is going to make you very good at it too. So we're going to do a lot of practice with this before we actually quiz or test you on it, because we want to make sure that you really understand how to put these things together. You will see them 2 different ways. One, sometimes they just have letters on them. I'm just going to pull this over to show you. And other times they have the actual map symbols on it. If they have letters, just use the letters. Usually on the regions they don't have the letters, but sometimes in practice they do. So this one is one with just letters. So you start with like the deposition of A, dep of B, dep of C, dep of D, dep of E, dep of F, tilting of all layers. Partial erosion of layers B through F, and then we would be dep of G. So I don't want to scare you with this, but I'm just saying in this case we're just using letters. The deposition of A, the deposition of B, the deposition of C. If they give you layers that you actually recognize, show you one of these. This one off of here. Let's find one here. There's one. Okay. Something like this, guys. Now there's letters on here, but there's also map symbols. In this case, you are allowed to use the letters. You really are if you're putting it back together, but I usually recommend that my students play it safe. You have the map symbols, go ahead and put what rock it actually is there, unless you can't tell. Like, look at layer M. If you're like, I think it's shale, but I'm not sure. Okay, then go ahead and put layer M. But if you can tell what it is, I usually have my students put the map symbols in there.